Hi guys, today we are going to teach you the laws of exponents and formula transformation. But for now, we are going to focus on the laws of exponents. Here are some important reminders which you should always bear in mind in using constants as the base. 0 has no exponents. Any constant, given the constant 1, is always raised to the power of 1. A constant raised to the power of 2, given 3 squared, is multiplied once by itself, given 3 times 3. A constant raised to the 5th power, given 4 raised to the power of 5, is multiplied 4 times by itself. Obtaining a power, given the quantity of 2 cm squared raised to the power of 3. We obtain the power of the constant, which is 2. That makes it 2 cubed cm squared times 3. So the exponents are the ones being multiplied. That would give us a product of 8 cm raised to the power of 6. Another example for number 5 is the quantity of x squared y to the power of 4 raised to the power of 3. First, we distribute the exponents to each variable, x squared and y to the power of 4. That gives us x squared times 3 and y4 times 3. Remember that we only multiply the exponents. That would give us a final product of x raised to the power of 6 and y raised to the power of 12. 6. Given 25 cm raised to the power of 6 over 5 cm raised to the power of 2. But we are first to divide the constants because the operation is division. Then subtract the exponents since they have the same base. That would give us the final quotient of 5 cm raised to the power of 4. 7th. So this is another example of dividing exponents given that the numerator 9 meters cubed is smaller than the denominator 27 meters. To solve this, we are going to look for the greatest common factor of both numbers, which is 9, and divide the numerator and denominator by it. Giving us 1/3. Then we are going to place meters squared beside 1 since we subtracted the exponents because they have the same base. Our quotient would be 1/3 meters squared. We are going to have another example. Given 6 grams squared over 3 grams raised to the power of 8. So we're going to divide the constants first. That would give us 2 grams. And as you can see, we would get a negative exponent since 2 minus 8 would be equal to negative 6. To make it positive, we are going to make our denominator g raised to the power of 6 to make it positive, giving us the final quotient 2 over g raised to the power of 6. 9. Another thing in the laws of exponents is to find a power of a fraction. Given the quantity of 4 grams raised to the power of 4 over 2 grams raised to the power of 2. So first, we are going to simplify the fraction 4 grams raised to the power of 4 over 2 grams, or the expression located inside the bracket. So 4 divided by 2 is 2 grams raised to the power of 3. Since we subtracted the exponents, then raising the derived quotient to the power of 2, given the quantity of 2 grams cubed raised to the power of 2. So that would be equal to 2 raised to the power of 2 grams raised to the power of 3 times 2, giving the final answer of 4 grams raised to the power of 6. Aside from this method, we are giving you another way of solving the problem. So given 4 grams raised to the power of 4 raised to the power of 2, and the quantity of 2 grams raised to the power of 2. So we distributed the exponents. We are going to distribute the power, giving us 4 squared grams raised to the power of 4 times 2 over 2 squared grams raised to the power of 2, giving us 16 grams raised to the power of 8 over 4 grams raised to the power of 2. Then perform again the division of the constants and exponents. That would give us 4 grams raised to the power of 6, which is equal to your quotient earlier using a different method of solving. Another example, number 10, the quantity of 15 meters squared over 5 meters raised to the power of 3 plus the quantity of 2 meters squared times the quantity of 3 meters cubed squared. So this is a little bit of a combination of all the laws of exponents. We are first going to simplify the fraction inside the bracket. So that's the quantity of 3 meters raised to the power of 3 plus 2 meters raised to the power of 2 plus, so we're going to distribute the exponent. So that's going to be 3 squared meters cubed times 2. So we're going to do the same with the quantity of 3m raised to the power of 3. So that's going to be 3 cubed meters cubed plus 2 meters squared. Then we're going to simplify 3 squared plus 9 meters raised to the power of 6 equals, but don't forget the cubed constant, 3 cubed. So that's going to be 27 meters cubed plus 2 meters squared plus 9 meters raised to the power of 6. This would be the final answers since we can no longer simplify the terms. Since we are done with the laws of exponents, we are going to proceed to the formula transformation. So formula transformation are for literal equations. So when we speak of these literal equations, these are equations made up of variables. So that's A, B, C, D, E, F. All the alphabet. Example, S is equals to D over T, and F is equals to M times A. But as everything in the world, there are rules to be followed during the formula transformation. First is the method of transposition. So this is 4 equations where addition and subtraction are involved. Second is cross product, wherein multiplication or division is involved. And the last is the squaring or extracting square roots. So this usually deals with exponents and radicals and the radical signs. We already have the rules. Now we're going to apply them. Given example number 1, the formula for the volume of a rectangle is V equals length times width times height. Find H. The goal of the process is to isolate H at either side of the equal sign, so it will be easier. We're just simply going to divide both sides of the equation with the value of length and width, leaving H by cancelling length and width at the right side. So the formula in finding the value of H is H equals V over L times W. Another example, number 2, E is equals to T plus U, wherein we are going to find the value of U. So the first step is to transpose the value of T to the left side of the equation, thus isolating U. Example, VF equals VI plus A times T. Find the value of VI. So we are going to transpose the value of A times T to the left side. That makes VF minus A times T equals VI. We could rewrite that as VI is equals to VF minus AT. Example 8. So now we are going to deal with squared variables. Given a squared plus b squared equals c squared, as you notice, it's the Pythagorean theorem used in right triangles. So in this equation, we are going to find the value of b. So the first step again is to isolate b. So we are going to transpose a squared to the other side. That makes it negative a squared. Next, so number 9, given degrees Celsius is equal to 5/9 times the quantity of degrees Fahrenheit minus 32, wherein we're going to find the value of the degrees Fahrenheit. So again, our goal is to isolate degrees Fahrenheit. So our first step is to distribute 5/9 to the quantity of F minus 32. That makes it 5 times the quantity of degrees Fahrenheit minus 32 over 9. Then we're going to cross product or perform the cross product method or multiply 9 to both sides. And distributing 5 to the quantity of F minus 32, that makes it 9 degrees Celsius is equals to 5 degrees Fahrenheit minus 160. Again, we're going to isolate degrees Fahrenheit here. 9 degrees Celsius plus 160 equals 5 degrees Fahrenheit. Still, we don't have the value of degrees Fahrenheit, so we are going to divide both sides by 5, canceling 5 degrees Fahrenheit, leaving degrees Fahrenheit alone. So our equation or formula would now be degrees Fahrenheit is equal to 9/5 degrees Celsius plus 32. Example 4. Given force is equals to mass times acceleration, wherein we are going to find for the value of m. So the first step we are going to do here is to do the method of cross product or simply dividing both sides by a. So we cancel a, thus isolating m. Then rewrite the equation in terms of m, which is m is equals to force over acceleration divided by time. So again, this is going to involve the method of cross product or simply dividing both sides or multiplying in this case. So we are going to find the value of d or distance. So we are going to multiply time on both sides, giving us speed times time is equals to distance, or rewrite the equation to d is equals to s times t. Example 6. So this is going to involves rather a squared variable. So given area is equals to pi r squared, wherein we are going to find the value of r. So what we are going to do first is divide both sides by the value of pi, leaving r squared. So that makes it a over pi is equals to r squared. The next step would be extracting the root of r squared. So we are going to cancel the square root since we extracted already, leaving our equation to r is equal to the square root of a over pi. So that would be the formula in finding the value of r. So this is the famous formula of Albert Einstein. E is equal to mc squared. So in this equation, we are going to find the value of c. So the first step is to divide both sides by m, or do the cross product method, leaving c squared at one side of the equation, equal to e over m. Next, we're going to extract the root. So c is equal to the square root of e divided by m. So that's it for today. We hope you have learned something from this video tutorial on the laws of exponents and formula transformation. Till next time!